So for 19, you want to read what they want you to do, see how many transformations there are. So on this particular problem, you can see there's a reflection, and then they're followed by a translation. So we have to do two separate transformations. Now down here, we have written the points down already. If they're not written down for you, like down the bottom, you want to start by writing out the points, because we're going to have to make a chart that does each of these transformations so we don't get confused. The only way to really get these wrong is to not be organized. As long as we're organized, things work out really well. So let's start out this way. And having a small straight edge here when you're doing this might be useful, but it might be easier for you to do it anyway. Here. So start by just saying, this is x comma y. Okay. Make a table, like so. So we have room to do each of these transformations. It's well worth the time to stay organized, because we're just adding, subtracting, taking opposites on all these problems, but people still miss it, usually because they're trying to do everything in their head and not slow down and just show the work. So take the time, just show the work. Now you still need your sheet possibly. Some of you might have these memorized by now, but if not, just have it there just in case. What is the transformation for a reflection over the x-axis? X comma negative y. Right? And then this component form right here, what is that in coordinate form? So -3 means x minus 3 and y plus 2. So we have to do each of those correct and then plot the results. We should be good. As long as we don't make any arithmetic errors, it should be fine. So we have the first set. Negative n is called x comma negative y. We have 2 positive 4. We have 2 comma positive 1. And we have 5 comma positive 2. So these are A prime, B prime, and C prime. And this is where, in the past, we'd normally be done, but now we're going to do one more transformation, which is a translation, 3 to the left and 2 up. So each of these x's I'm going to subtract 3 from. Each of the y's I am going to add 2. So x minus 3. 2 minus 3, negative 1. 4 plus 2 is 6. Then we have 2 minus 3, which is negative 1. And 1 plus 2 is 3. 5 minus 2 is, 5 minus 3 is 2, and then 2 plus 2 is 4. Now, since these are the second image, we usually call the first image like A prime, B prime, C prime. These are going to be A double prime, B double prime, and C double prime, almost like quotation marks for each one of those. And then we just have to plot them correctly. Negative 1 comma 6. No, just the final. Just the final we need to plot. And then we have negative 1 comma 3, 2 comma 4. So we got A double prime, B double prime, and C double prime. As straight as possible. Go ahead and connect these. Now these are rigid because there's no dilations. As long as we're just doing the opposite and adding, subtracting, rotations, and translations, and reflections, you should have the exact same shape and size. So if you do this and there are no dilations at all, if it's not the same shape, then you know something's wrong. Don't just move on and say, okay, I guess I'm done. If it's not the same size and shape, you might have missed one negative somewhere. Okay. But that's the process. That's as difficult as it really gets. Some of these have you doing rotations. Some of them have you doing some dilations down at the bottom where you have to take half of x or triple x or -2 of y or 3 over 2 of x or something like that. But it's really just setting it up and being organized and following through and just being very careful on your details and not messing up on some simple calculation. So since there's so many little calculations, some like to have a calculator just to make sure they're not messing up on negatives, but it's good practice making sure we're doing everything 100% correct. And it is worth time just to set this up. Make a nice table, it's organized. It's usually those that see this that think it's too easy to mess up on and start skipping steps, not making the table. Those are the ones that end up missing it. Most don't miss it at all. Okay. There we go. So first step, using our paper, we need to rotate this clockwise, this shape clockwise down here. So what is the transformation for a 90-degree clockwise rotation? What's that? Negative y x. Well, is your paper, is it listed counterclockwise or clockwise? Okay, so we need to go clockwise, right? So counterclockwise, this would be 90 degrees counterclockwise. So that's not the direction we want to go. So how do we get to over here? Yeah, so this would be the 180 counterclockwise, and then down here would be the 270. So a 90 degree clockwise is the same as 270 degrees counterclockwise. So we needed to use the 270 that's on your paper. So even though the arithmetic is simple here, if we're not careful on what we're actually doing and we're just saying, oh, 90, 90, okay, it's all the same, we might still make mistakes. So details are important. So we want to do a 270 degree counterclockwise. In that case, the proper transformation is what? Y negative x. Okay, good. And then our, let's see here, reflection over the y-axis. What is that? Reflection over the y-axis. What does it say on the paper? Negative xy. There we go. So we're going to do first the rotation, then the reflection. So first set up the table, get 1, 2, or all 3 of the transformations figured out and which the right one, and then the last is just do all the arithmetic and then finally plot it. So y negative x would be 2 comma negative 3. Then we'll have 5 comma negative 3. And lastly, we'll have 2 comma negative 7. Okay. Then we have negative x comma y, so now we're going to have the opposite of 2 comma negative 3, stays the same. We'll have the opposite of 5, negative 3, stays the same. And the opposite of 2, and negative 7 stays the same. don't know. Okay. And make sure you label these double prime. We got x double prime, y double prime, and then down here is z double prime. Okay. Now, like always, if you think you got the hang of this, go ahead and try this one on your own. First, we got to rotate 180 degrees on number 3. Is that clockwise or counterclockwise? Rotating 180 degrees. Is that clockwise or counterclockwise? Either way, yeah, it's the same thing, right? So that's why on your paper it doesn't say counterclockwise, clockwise for 180, because it's the same thing regardless of which direction you go. All right, so what is the transformation for 180 degrees? Yeah, take the opposite of both, x and y. Okay, good. And next, we're going to translate. It's like to the right 2 and down 5. Okay, to the right 2 and down 5. All right. And little note on Q, what's the correct coordinate for Q? What is this coordinate? What's this x? -4. What's this y? -4. So it should be -4 comma -4. Little typo in there. So we just start off with 4 comma 4. And then we can add 2, get 6, and subtract 5, -1. Then we'll have 5 comma +2. Add 2, 7. Subtract 5 from 2, we'll have -3. And then lastly, we'll do +2, +3. 2 plus 2 is 4. And 3 minus 5 is -2. Oh, 7 negative. There we go. Okay. And once again, we do have a rigid transformation, so same size and shape as expected. Let's label them with the double primes. There we go. So far, so good. If you've already gone past, that's perfectly fine. The next three are the same organization, same everything. They give you the transformations. You don't have to look at the sheet here. These are non-rigid, so when you find your double primes and plot them, they will not be the same shape and size because we're going to triple the x and then take half of it and then take the negative half of y. So okay if they're not the exact same shape and size. Yes. Yeah, you'll see here in the middle we have 1 prime, double prime, and then triple prime. So 3 transformations on here, so we'll just have an extra column on that particular problem. Now they don't give us the coordinates are not listed there for you, so you have to do that yourself. So x comma y. And we'll list a, which is 0, comma 2. Is that right? And be careful, it's negative 2. So believe it or not, this is the part where most of the mistakes happen. People get so focused on doing the transformations right, they might forget a negative from the very, very beginning, and that throws everything off. Okay, it's kind of like copying down the problem wrong on your paper. You're solving a different problem if you don't write these down correctly. So B, we got negative 2, negative 4. And C, we have negative 4, comma negative 4. All right, and we got to do the 3x, comma y. Pink. Okay. So we're just going to triple each x and keep y the same. So tripling 0, you get 0. Y stays the same. Tripling negative 2, you get negative 6. Y stays the same and negative 4. Tripling negative 4, we'll get negative 12. Y stays the same. And then we get to go through and take half of the x's and opposite of half of the y's. So 2 steps. We'll take half of it and then take the opposite sign. So we have half of x is still half of 0 is still 0. Half of negative 2 is negative 1. Take the opposite of negative 1, positive 1. And just repeat, half of negative 6, negative 3. And then we have to take half of negative 4, negative 2, take the opposite, positive 2. And we take half of negative 12, negative 6. Half of negative 4, same as the one above, so we already know this will come out to positive 2. So we got 0, comma 1 for A double prime, -3, comma +2, or B double prime, and then -6, comma +2. All right. It's okay, it's not the same size and shape because this is non-rigid as it says right above. All right. So x minus 1, y minus 1 should get 1, comma 1, 1, comma 4, 2, comma 1. Okay. And then we'll just triple x, keep y the same. So 3, comma 1, 3, comma 4, and 6, comma 1. And then lastly, do one more, which is just to the opposite of each coordinate. So we'll have -3, -1, -3, -4, and -6, -1. Okay, so that should be a little more accurate. There we go. So got A double prime, B double prime, and C double prime. Okay. Let's get the last one started here. Our coordinates should be 2, comma 1, 0, comma 2, 4, comma 3. And then our next transformation is 3/2 of x, which is the same as 1.5. So let's get 1.5 times bigger. And -2y. And lastly, we're going to go left 5 and then up 4. X minus 5, and then move it up 4. There we go. A little side note about multiplying by 3 over 2. That means multiply by 3, divide by 2. So it's really just a multiplying and then a division. So 2, if you want to write up to the side, it's 3 over 2 times 2. So that's 3 times 2, which is 6. 6 divided by 2 is 3. Or you could just cross off the 2's and you get an answer of 3 as well. The next one down for the x is going to be 3 over 2 times 0. So that's just 0. And then next one down be 4 times 3 over 2. So 3 over 2 times 4 will be 12 divided by 2, which is 6. Or you could cross cancel, say 2 goes into 4 2 times, and then 3 times 2 is 6. Or there's a calculator. Just type it in a calculator. And the y coordinate will just multiply by -2. So 1 times -2, 2 times -2, 3 times -2. Double check my work. All right. So now I'm going to subtract 5 from each. 3 minus 5 is 2. 0 minus 5 is negative 5. 6 minus 5 is negative 1. So far, so good. No one? Thank you. 3 minus 5 is negative 2. Negative 2 plus 4 is 2. Negative 4 plus 4 is 0. Negative 6 plus 4 is negative 2. So watch your negatives. Be very careful as you're doing these. Please, please, please. We have negative 2, positive 2, a double prime, negative 5, 0, and negative 1, negative 2. There we go.